Okay, so let's look at that example from the previous video in a little more detail. We're going to try to draw a rough approximation of our derivative and then our second derivative. So here we've got positive going to 0 here. So I know that my derivative is going to be 0 at all these stationary points. I know it's going to be negative through this bit, and I know that it's going to be positive from there onwards and positive start. So it's going to look something like this. Going through there, it gets quite positive, comes back, but then goes back up again. So we've got something like that is my first derivative. Now my second derivative, well, the stationary points here are going to be zeros on this one. So I've got a stationary point there, a stationary point there, and a stationary point there. My second derivative is going to be negative to start with, comes up to this point here, becomes positive, comes this point here. Sorry, it's a little bit offline. I'm going to redraw that and then here. So here it becomes 0 again. It's negative for a little bit through this bit, and then it goes positive again. So that's my second derivative. Now, if we trace these points up, we can see that that was a point of inflection where it went from one direction to the other. This here, again, is a point of inflection where it's gone from one to the other, and this one, again, a point of inflection. So those zeros on the second derivative correspond to points of inflection, and this section here where this is negative corresponds to this being, and I'm going to change the language I use. So I'm going to say that's concave down. We can think of that as sort of a cave pointing downwards. Here where it's positive corresponds to a part of the graph where we say concave up. So rather than concave and convex, I realize that would be a little bit confusing. So concave down, showing it cave going downwards, concave up going upwards. And there's a little bit here that's a little bit concave down. Only you see a little bit of it, and then a little bit concave up. So that's corresponds to those values. So how does that affect what we're talking about when we're talking about stationary points? Well, if we've got our second derivative being positive, let's bring that back over here to look. So during this part here, it's positive. That means it's concave up, which means I've got a local minimum. And now, where I've got our second derivative being negative, that means that I'm concave facing downwards, which means I've got a local maximum. Now, that's always going to be the case. Now, the points where it's 0, we know that we've got a point of inflection. And normally, or usually, that would be a stationary, ran out of paper, point of inflection. But here's the one downside of using the second derivative. Sometimes it could be a maximum or a minimum, and you sort of have to check with one of your other techniques.